Alright, so I think we're recording. I got a little bit lucky. During that last video, this started flashing, and I thought for sure I have so many problems losing so many videos that I thought no way is that going to have recorded and been able to upload to Edpuzzle, but I think it did, and I think everything's fine. So I got kind of lucky that time, which is rare. So let's finish this problem number 3. We're finding the domain of a composition. The domain of any function is the set of all real numbers, excluding any values that cause division by 0, also excluding any values that cause us to take the square root or even root of a negative number. I want two things to always be true, that need to be true when I'm finding the domain of a function composition. The input into our first function has to be in the domain. So x has to be in the domain of f. If it is, this function will produce an output, a y value. That now becomes the input into the next function. So anytime you have an input into a function, that input needs to be in the domain. So f of x needs to be in the domain of g in order to have an output. Now, in the previous videos, in the previous parts of this problem in A and B, we found the domain of f and the domain of g. The domain of f was all real numbers excluding the number 3. The domain of g was all real numbers excluding the value -1. Now, the most difficult part in finding the domain of these function compositions is to recognize that g will never see the input x. It sees the output from f of x. So when we say that we do not want the g of x to be equal -1, it's probably better to say that we do not want the input to be -1, because the input into this function is f of x. I do not want f of x to equal -1, because if it does, it's going to cause me problems. I won't have an output. Well, what is the expression for f? See, I'm temporarily going to have to let it equal -1 in order to know what to avoid. So with f being x over 2x minus 6, if this equals -1, and let's write it as -1 over 1, we need to solve this equation. This equation is a proportion, so we can cross multiply. One technique to solve proportions is to cross multiply. So we cross over the equality, we multiply along the diagonals. Along that yellow diagonal, x times 1, hey, that's x. And this guy, this -1, times the quantity 2x minus 6. So I have x is equal to -2x plus 6. If I add 2x to each side, I'll get 3x is equal to 6, and I know that 3 times 2 is 6, so x is equal to 2. So if x equals 2, what's going to happen? If we input a -2 into f, what comes out of f is a -1, and everything's fine. You're like, hey, this is going fantastic. -1 goes into f, and we've got a problem because it causes, -1 goes into g, and we've got a problem because it's undefined. G is undefined at -1, so we don't get an output. So in order to prevent g from seeing -1, we have to prevent x from ever equaling -2. Alright, so we have both of these restrictions to consider when writing the domain of our function composition g composed with f. We knew that x could not equal 3 because that was easy looking at the domain of f. But it's not always quite so clear to all students of why we're excluding -2. We're excluding -2 because -2 leads to a -1, which causes a problem in the second function. you don't get through the assembly line. When we try to evaluate g of f at -2, the output is undefined, and because we're fine with -2 going through the first function f, it's that output of f that does not make it through g. All right, so let's write our domain of Goff is all real numbers excluding -2 and also excluding +3. So for part D, here's my final. I thought that was highlighted in yellow. I don't know why I thought that was funny. My final answer for problem 3, part D, and this time down at the bottom my icons didn't start flashing, so that's good. Last time it made me nervous when it did. So I hope that helps, and I'll move on to the next problem in another video.